So we are starting with the three-phase connection. Before that, you must know basically there is first two types of connection. One, we are having a single phase connection, okay, and another we are having three-phase connection. Single phase connection, or we can say single phase supply, that we are using at our home appliances. Okay, you will have a this kind of socket now at your homes, right? Hmm. So in this, if you have studied about, this one is phase, this one is neutral, and this one is for mainly ground purpose. Correct? Tell me. Phase means a single phase supply, right? From where the current is entering, and through the neutral the current is coming back. So similarly, in the three-phase supply, we'll have three wires having different connection, means having different current. Basically, single phase means single phase wire having wire current, and three phase means three wires having current. Okay. So this will have a fixed color. One is of which color? Red color in India according to India notation. Another is for yellow color, and another is for blue color. So we'll have three different wires with three different colors, red, yellow, blue. Okay. Now I am saying you that you need to connect these wires. Okay. So how can you connect these wires with each other? One, you can do like red can be connected with yellow, and yellow can be connected with blue, right? This is one of the connection. Or another connection, you can do it like red is connected with yellow like this, and it is would be connected with blue like this, right? Or tell me, is there any another possible combination also? Yes or no? Hmm? Is there any another possible combination? No, na. So technically it looks like a delta. That's why we called it as a delta connection. And technically it looks like a star. So that's why we called it as a star connection. Clear? Hmm. Okay. No, this is the three phase. Yeah, it is star delta. But see, your module I'm teaching you module 2 AC circuit up to power factor. You already get in CAT 1 exam. After this, there is a topic three phase balance system, that is star and delta connection. Okay, this topic I am teaching you, and in your VIT one question 100% will come from star and delta. Every time if I'll see the previous year question paper, one question of star and delta will be there. Okay, clear? Now see, next one we need to study about star and delta in detail. Okay, so first one we are having star connection, right? In the star connection we'll have, as you know, the star connection looks like this, right? In this we'll have one winding. Okay, this one is suppose red color, this one is suppose yellow color, and this one is suppose blue color. And if you are having one plain wire, like we are having one plain wire now, like this, if we are having one plain wire, then in that case that is technically known as line. Clear? And if we are having a one winding like this, we are having winding like this, then technically it is denoted by phase. Got it? Plain wire is denoted by line, and phase wire is denoted like winding wire is denoted by phase. Now in this we need to mark the currents. So see, how will we mark it? The current flowing across R would be IR, current flowing across Y would be IY, current flowing across B would be IB. Okay, and this is the point neutral where it is denoted by N, and neutral current is also there, that is denoted by IN. Clear? Now from here, between N and R, here let us consider the current flowing is NR, here the current flowing is INY, and here the current flowing is INB. Okay, clear? So can we say that IR and INR, tell me, both are equal or different according to you? You tell. So we can say similarly IY is equal to INY and IB is equal to INB. Can we say it like this? Hmm? Okay. So basically the wire, the current across the plane line, that is known as line current, and line current is denoted by IL. So can we say that IL is equal to IR is equal to IY is equal to IB? Hmm? Because all these green wires, these are the plane wire, and the current flowing across the plane wire is denoted by the line current, that is IL. Clear? Now the current flowing across the winding is known as phase wire, right? So phase wire is denoted by IPH. So can we say that IPH is equal to INR is equal to INY is equal to INB? Yes or no? Hmm? So IPH is the current flowing across the winding. So from this conclusion, can we say that line current is always equal to the phase current? Yes or no? Line current is always equal to the phase current, right? So this is what we need to know about the star connection, that in star connection line current must be equal to the phase current. Okay. Now similarly we'll discuss about the voltage. Okay, derivation is not there, like it will not come in your paper, but to understood the numerical concept you should know what is going on in star and delta. So I deeply tell you that what is exactly the line current and what is exactly the phase current and with why they both are equal. Clear? Now we are talking about the voltage in again the star connection only. Like suppose this is R, Y, B and this is N, right? So the voltage across the plane wire, as I told you earlier, that R, Y, B, these are the plane wires and they are denoted by line. So the voltage across plane wire between R and Y, we can denote it by VRV, right? Between VYB, we can denote it by VYB. And now tell me what we can denote it for between R and B. That would be, tell me, VRB, right? Right or not? Hmm? Okay. Now, now tell me, these are the line voltage, right? Because these are across the plane wire. So VL is equal to VRY is equal to VYB is equal to VRB. Correct? Now again the voltage between the winding, like between the winding is VNR. This would be VNR. This would be VNY and this would be VNB. All these are line voltage or phase voltage? Hmm? VNR, VNY and VNB. These are the phase voltage because these are across the winding. So can we say that VPH is equal to VNR is equal to VNY is equal to VNB? Yes or no? Hmm? Okay. Now tell me, will the VNR and VRY, it should be equal or it should be unequal according to you? I'm again saying VNR and VRY. It should be equal or unequal? No, because see, they are not equal. See, as you can see, VRY is made up of VNR and VNY, right? So we can't say that VNR is equal to VRY, right? So these are unequal and will have one relationship. What was the relationship? That line voltage is equal to root 3 times of the phase voltage. I'm not teaching you the derivation because derivation will not come. Okay. So I'm telling you the direct formula, that what is the relation of line voltage with phase voltage. That is, line voltage must be equal to root 3 times of phase voltage. Got it? So wrote it down, this formula. Now what we conclude, that in the star connection, line current is equal to the phase current and line voltage must be equal to root 3 times of phase voltage, right? These two formulas you need to remember. One more formula you need to remember, that is according to Ohm's law. Ohm's law is what? V is equal to IR, right? But instead of R, if we'll have the, now in the case of impedance, we'll use V is equal to I into Z, right? Z is the impedance, and can you tell me, like, suppose this is the Z, right? This is Z, and can you tell me this Z, this is Z, suppose this Z is in present in phase or it is present in line? According to you, Z is present in phase. As I told you, inductor windings are always in phase, right? So if Z is in phase, then we need to take current also in phase, right? And voltage also in phase. So now we'll have one another formula, that VPH is equal to IPH into ZPH. Maximum of the student do this mistake, that they'll use VL is equal to IL into ZL. Okay, so write down this formula as well and cut it down like this, so that you won't use this formula. I am saying like 80% of the student do this mistake, that they are using this formula, but this formula doesn't exist. We are having only this one formula, VPH is equal to IPH multiplied by ZPH. Okay, write down this formula as well. Done? Okay. Now see, they'll never give you ZPH directly. They'll give you like impedance is equal to, suppose they'll give you 2 plus J4, right? So we'll have one formula for impedance, that is Z is equal to R plus JXL for RL component. R is for resistor and L is for inductor, right? But if they want to give you RC, then they'll give you Z is equal to R minus JXC. So you need to remember this thing also. If minus is there, that means that would be the capacitor component, and if plus is there, then that would be the inductor component. Okay, and from there, if you want to calculate Z, then there is a formula for Z. If that is the R plus JXL, then Z formula is root of R square plus XL square, right? And if it is RC formula, then there is a formula for root of R square plus XC ka whole square. So in both the cases, the formula would be same. From here we can calculate the Z, and you know impedance unit is a kind of resistance only, so its unit is ohm. Got it? Understood up to here? One more thing you need to write it down in the formula page, like make one separate formula page, okay? And put it down the heading, that's 3-phase connection, star connection, and in star you need to write all those formulas. One thing you need to mention, one, that they'll generally give you the voltage, and that voltage is always the line voltage. Okay, in the question they'll always give you the line voltage until and unless they didn't mention you the voltage. Clear? If they mentioned it, then you have to take that one only. If they didn't mention it, then you need to consider that voltage as the line voltage only. Clear? Note down this point also, then I'll do numeric. Now this is your FATEC question paper from 2023 February. So see what they have said in the question, a 415 volt, right? As I told you, if they didn't mention that, in that case we need to consider that voltage as the line voltage. So that means line voltage, if they no, if they have mentioned that this is the phase voltage they have given, then only you need to consider the phase voltage. Now in this case they didn't mention anything whether it's a line voltage or the phase voltage, so automatically we need to consider it as a line voltage only. Okay, so whatever they'll give you in the question, you need to write it down side by side. Like they give you 415 volt, means you need to write down VL is equal to 415 volt. Okay. Next they are giving you frequency. Frequency is how much? 50 hertz, right? Now they give you three phase supply, a star connected. Okay, we are doing the star connection. Write it like this. Balance load through a line impedance 2 plus J4, means they give you the line impedance Z line is equal to 2 plus J4. Okay, the load impedance per phase consists of 10 millihenry and 6 ohm connected in series, means they give you the load impedance of how much? R is equal to 6 ohm. They give you R 6 ohm resistance, and L they have given you the 10 millihenry, right? Now what they are asking, calculate the load current in each phase, means they are asking IPH. Okay, now first of all tell me you understood the question, and yeah, now you tell me how can we get the value for IPH. So now ZPH is R plus JXL, 2 plus 6 is 8. So from here we need to calculate XL because they have given you L. So how can we calculate XL? By using the formula of 2 pi FL. 2 we know, pi we know, frequency is given, L we know. L is 10 millihenry, so we need to convert it into 10 raised to power minus 3 henry, right? Calculate the value of XL and then let me know, because it would be like J4 plus, tell me what will you get the value for XL? So it would be J 3.14, right? So J4 plus J 3.14, how much it is? 8 plus J 7.14. So now you get the value for ZPH, yes or no? Now tell me, any doubt up to here? But they are not asking the impedance, they have asked you to IPH, load current in phase. That means we need to calculate IPH, right? And as you know the formula, VPH is equal to IPH multiplied by ZPH. ZPH we have calculated, that is 8 plus J 7.14, right? IPH we need to calculate it. Can you tell me the relationship of line voltage and phase voltage in star? That is VL is equal to root 3 VPH. So we don't know the value for VPH, we know the value for VL. So VPH is how much? Right? VL by root 3. VL is how much they have given in the question? That is 415 volt. So that would be 415 divided by root 3. Correct? So as I told you, we can solve it 8 plus J 74.4. How I can write down? That Z is equal to root of R square plus XL ka square. So it would be R square plus XL ka square, right? And this one is as it is. Now can you'll have VPH, you'll have ZPH. Can you get the value for IPH? Yes or no? Solve it and then tell me the value for IPH. That would be in ampere, right? Solve it. It can be 23. We can consider it as final answer is 23 ampere. Okay, clear? Now they are asking the active power, reactive power, power factor. Like if you know about it, remember, we'll have three types of power. One is the active power, another one is the reactive power, and another one is the apparent power, right? Active power is denoted by P, reactive power is denoted by Q, and apparent power is denoted by S. Active power formula is VI cos phi, that is I am telling you for single phase. Reactive power formula is VI sin phi. Apparent power formula is VI. Active power standard unit is watt. Reactive power standard unit is VAR. VAR means volt ampere reactive, and apparent power standard unit is VA. VA means volt ampere. Okay. Where we are using active power? In resistive load. Where we'll use reactive power? In inductive or capacitive load. Where we'll use apparent power? In RL, RC, and in RLC. Got it? So now what you need to remember, the formula, that active power formula is VI cos phi, reactive power formula is VI sin phi, and apparent power formula is VI. Okay? So now put down this formula in your formula page only here, like active power formula for the three case that we are studying for the single phase, but now we want it for the three phase. That would be how much? Root 3 VL IL cos phi. Okay? And if you want to write it in terms of phase, then that would be equal to 3 VPH IPH cos phi. Similarly, reactive power formula for the three phases, root 3 VL IL cos phi, and for that would be phase in terms of 3 VPH, sorry. For reactive power it is sin phi. For this one, 3 VPH IPH sin phi. And apparent power is for the line root 3 VL and for the phase 3 VPH IPH. Okay, understood? Write down these formulas in your formula sheet only. Now see, we should know one more thing, what is cos phi. Cos phi is how much? If you know about it, cos phi is equal to simple R by Z. So from here, if we want to calculate active power, root 3 we know. Do we know VL? Yes, 415 given in the question now. Do we know IL? IL is equal to IPH only because it's a star connection, as I told you that in case of star connection, IL is equal to IPH. So that is 23 ampere, right? Now we don't know cos phi. Cos phi is how much? R by Z. But we know R and we know Z. R is how much? 8, and Z is how much? That you need to calculate, right? So that was the formula. Z is equal to R plus JXL. R we are getting as 8, and J is how much? 7.14. So cos phi is how much? R over Z. R is 8. Can you tell me what would be the value for Z you are getting? 8 ka square plus 7.14 ka square. How much it is? तो cos phi we are getting as 0.7. तो हमारे पास will have P active power, right? Only from one formula you need to calculate. Okay, either this one or either this one. Answer would be same. Now similarly, you will get Q reactive power. Now see, if you'll have cos phi, then can you calculate sin phi? You'll have two options. One is you can use the formula cos square phi plus sin square phi would be equal to 1. Okay. And second option is you are getting cos phi as 0.7. So phi is how much? Cos inverse of 0.7. and cos inverse you can calculate it from your calculator only, right? And then after that multiply it with sine by both the terms. You will get the same answer from this method or by this method. Clear? This one, cos phi is 0.7. How will you get phi? By cos inverse and then multiplied with sine, then you will get sine phi, right? Yeah, right. Cos phi we will get it from for we need to calculate cos phi for active power and we need to get sine phi for reactive power. So we need to calculate both the values. Okay. Hmm? Now next they are asking power factor. Power factor is again cos phi only and cos phi you already calculated, that was 0.7. So see, this is the 10 marks question and every time you will get this kind of question only. Either it would be based on star or it would be based on delta. See, this is the star connection now. So for VPH we are having this formula and for ZPH we need to use this formula. So now we'll apply VPH is equal to IPH multiplied by ZPH. Okay. ZPH is how much? 8 ka square plus 4 ka square. VPH is how much? VL by root 3. VL is 400. So 400 by root 3. So from here we can get IPH. Yes or no? Hmm? Calculate IPH and then tell me the value. So basically this is also the question from your FAT exam. They have given ZPH and VL. So from VPH we'll get it this value, ZPH we are getting this, and after solving we are getting phase current and phase voltage, because they ask you to calculate phase voltage and phase current only, right? And this is also 10 marks ka question. Now see, in this question line voltage is 400 volt, XL and R they have given. Again we'll use the same formula, VPH is equal to IPH into ZPH. ZPH is 24 ka square plus 32 ka square, right? And VPH is 400 divided by root 3. Then after solving we'll get IPH as 5.6 ampere. So this is about the star connection, but we haven't done till delta connection. So now let's do delta connection also. Another type of connection is known as delta connection. Okay. See, delta connection is like this. Windings. In this we are having 3 wire connection. One is R, another one is Y, another one is B. R for red, Y for yellow, B for blue. Okay. Now again, as you know, the voltage across line, the plain wire between R and Y, it would be VRY, right? Voltage across Y and B, it would be V by B, and the voltage across VRB is VRB. So can you tell me these are the line voltage or the phase voltage according to you? These are across the plain wire. Tell me, these are the line voltage, right? Correct. So now I am marking across the phase. Let us consider the voltage across 1 and 2 would be V12. Voltage across 1 and 3 would be V13. Voltage across 2 and 3 would be V23. So now tell me, these are the line voltage or the phase voltage? Phase voltage, because these are across the winding. Now tell me, V12 is equal to VRY or not? This one is VRY, right? That is connected between R and Y. This one is V12. Again, it is also connected between R and Y point only. So these two voltages are same or different according to you? These are the same voltage, right? So can we conclude that VL would be equal to VPH? Means in case of delta connection, voltage is same. See what we got it for star connection, that current is same, IL is equal to IPH. But for delta connection, it is always opposite, that VL is equal to VPH. Okay. Now for star connection, VL is equal to root 3 VPH, right? But for delta, we'll get again opposite, that IL would be equal to root 3 of IPH. Let's see how. Again, I'm drawing for the delta connection. Now we'll see according to the current. This is R by B. Okay. 1, 2, 3. Let's mark the current in plain wire. In R, it would be IR. In Y, it would be IY. In B, it would be IB. Right? So what we can write down? IR is equal to IY is equal to IB is equal to the line current IL. Yes or no? Now tell me, current across 1 and 2, it would be I12. Current across 1 and 3, it would be I13. I'm marking the direction randomly, okay? It's not a fixed direction. Current across 3, 2 will be 322. So I13 is equal to I12 is equal to I32. These are the line currents or the phase current? Tell me, these are flowing across the windings, right? So these are the phase current IPH. Now tell me, will I12 and IR equal or unequal? Unequal. So we can say that line current is equal to root 3 times of IPH. So see how it comes root 3 times, you don't need to learn the derivation. So that's why I'm not telling you. Okay. So write it here also, IL is equal to root 3 IPH. Power formula is same for both the cases. Power is equal to root 3 VL IL cos phi and Q is equal to root 3 VL IL sin phi and S is equal to root 3 VL IL, or you can write it in terms of VPH also. 3 VPH IPH cos phi, 3 VPH IPH sin phi and 3 VPH IPH. So these power formula is same for star as well as for delta. One formula, VPH is equal to IPH into ZPH. This is also same for star and delta. Another formula, cos phi is equal to R over Z. This is also same for star and delta. Another formula, Z is equal to root of R square plus XL square. This is also same for star and delta. What is the difference? Only the voltage and the current. Or you can take the screenshot or you can write it down. Now for the delta connection, VL is equal to VPH. So how much? VL is equal to how much they have given? 400. So that is VPH is 400 volt, right? IPH we need to calculate it by the same formula, that is VPH over ZPH, right? And ZPH formula is root of R ka square plus XL ka square, that you have calculated in star also, 24 ka square plus 32 ka square, right? How much you got it for Z? 40. Okay, for now voltage is 400 volt, ZPH is 40. So how much you are getting? IPH. IPH you are getting as 10 ampere. Okay. But now they are not asking IPH. See, they have asked you to determine the current drawn from the supply. That means they are asking IL. So now in delta, you know, IL is equal to root 3 IPH. So that would be root 3 multiplied by 10. How much it is? 1.732 multiplied by 10 is 17.3. If you were calculated from delta, then current is 17.32, and you calculated from star, that is 5.32 approximately, right? 5.6 something maybe. So see, as you can see the difference, if you use delta, line current drawn from the supply is more, and if you do it from the star, then the supply current would be less, right? So this is they want to show you the difference. Got it?